Hello, hello, and what's up to you all wonderful and awesome mindsetters. Happy spring. It is the first day of spring today. It's September. Yeah, mindsetters, I hope you guys are excited as I am. Well, we welcome the new season, and I hope you guys are good. My name is Abram, and we're going to have a great show today. It is our Triple M day. It doesn't change. It is our Mindsetters Maths Monday. So welcome, and tell all your friends to tune in. Today, we're doing maths for grade 10s with Natasha. Natasha, how are you?
Hi, Abby. I'm very well, thank you. Great to see you in studio and great to see you so happy about spring. But unfortunately, it's not really spring yet, hey? I think it's closer to around the 12th of September.
Yes, yeah, but you know, it's a new season.
It's a new season. It's a new week. It's a new month. It's almost a new season. So it's time for everyone at home to also get into the spring fever. Hey, get ready for almost exam times.
Yeah, and what are we doing today?
All right, grade 10s. Today we're looking at more Euclidean geometry. Now, we have discussed geometry in detail in previous lessons, and today we're going to look at more the side of solving geometry riders using the theorems that you guys have already learned.
I'm glad we're doing this topic because today I got a feedback message from one of the mindsetters on Mixit saying, I want to learn more about Euclidean geometry. So I hope, mindsetter, you're watching because I did tell you that today we are doing it. So guys, all you need to do is to log on to facebook.com/learnextra to engage with us, to send us your comments and your questions, and also to help one another. Else, you can also tweet us on Twitter at LearnExtra. We have your notes on Facebook, so you can get them. But even in case you missed them or you want to watch previous shows and get previous notes, go to learn.mindset.co.za. We've got this awesome giveaway through our notes. All you need to do is to test yourself with a link that will be provided for you on Facebook, and you could win this awesome Casio calculator. And remember, on our Vodacom competition, we'll be announcing our Sony Xperia L cell phone winner today at 6 o'clock. So do tune in, and the airtime winners will be announced tomorrow. So, Natasha, back to you.
All right, guys. So, as I said already, we are looking at applications of the theorems you guys have learned so far to help you solve geometry riders. But first, I just want to remind you guys of our challenge question for today. You are given parallelogram ABCD. You are told that angle C1 is equal to angle C2. Let's just mark that off for you. So C1 is equal to C2, and D1 is equal to D2. All right. Angle A, they tell you, is equal to 2x, and they ask you to show that angle R1, which is here, show that that is equal to 90 degrees. All right, so hopefully that will keep you guys busy, but not too busy so that you guys don't pay attention to the show, because we are going to cover quite a lot of the basics that we have already done and just remind you of a couple of the theorems. And I want to urge you guys today, if you have any questions of your own, even if it's not something I'm doing in the lesson, but it is related to Euclidean geometry, please keep it in context of the subject we're doing today, then please send it through to Abram, or AB as I call him, and we'll have a look later and see if we can get to your questions as well. Okay, so just in summary, we really need the knowledge of all the theorems you've learned thus far for this entire lesson that we're doing today. You need to understand the properties of all special quadrilaterals, so that's your kite, your parallelogram, trapezium, rectangle, square, rhombus, all of those. And you also need to know how to apply, and you need to understand what the midpoint theorem says. So you need to know the statement of the midpoint theorem and how to apply it. With that, we're going to go straight into question 1, because geometry is one of those sections where it's all about application. You get better at geometry by practicing. Okay, so question 1, they tell you that ABCD is a parallelogram. Okay, when you hear the word parallelogram, straight away you need to start thinking of certain things. Like, for example, what are the properties of a parallelogram as far as opposite sides? So properties of parallelogram need to start ringing in your head. We know the opposite sides are parallel to each other, and they are equal to each other. Okay. Another thing that we know is that the opposite angles of a parallelogram are equal to each other. We know the diagonals bisect each other, and What else do we know? Opposite angles are equal, diagonals bisect each other, and both pairs of opposite sides are parallel and equal. So those are the main things that you need to remember. Those are the main properties you need to remember when you're dealing with a palm. Okay, in this specific question, they also tell you that K is the midpoint of AB. So they've marked it on your diagram, that's K there, and that's the midpoint of AB. That therefore implies that AK is equal to KB. The lines are drawn on your diagram. L is the midpoint of CD. Again, your equivalent points are drawn in, so LD is equal to LC. Show with reasons that KBLD is also a parallelogram. So KBLD, that's this one here. We're going to just highlight it in blue. We've got to show that that's a palm. But guys, in order for you to show that something is a palm, you need to understand what a palm is itself and the properties that you can use to show that a quadrilateral is a palm. So this is where it's important again to understand the properties of a parallelogram. As I said to you, you need to remember things like both pairs of opposite sides are parallel and equal. All right, and one of the ways that you can prove that a quadrilateral is a parallelogram is to show that one pair of opposite sides is parallel and equal. In this specific question, that's going to be the one that we use. That's going to be the property that we use to prove that KBLD is a palm. But depending on your question, you could also use the opposite angles of the quadrilateral are equal to show that it's a palm. You know, you need to draw on all the properties you know, and you see what best suits the figure that's given to you. All right, so I'm going to show KBLD is a palm by showing one pair of opposite sides is parallel and equal. So I have an idea of where I'm working towards. Now we need to understand how to get there. All right. So we know, firstly, that K, they told us, was the midpoint of AB. So let's just get a little bit of space in here. K is the midpoint of AB, so we know that firstly AB is equal to CD, and the reason for that is opposite sides of palm, and I'm going to use that abbreviation for parallelogram, ABCD. Okay, we know that the opposite sides of that palm are equal to each other. So AB, that entire length, is equal to that entire length. All right, K is the midpoint of AB. All right, so therefore we know AK is equal to KB, and that's because K was given as the midpoint. All right, you also know that DL is equal to LC, and that's because L is the midpoint of CD, and there we were talking about AB. All right, so DL is equal to LC, AK is equal to KB, but remember these two lines are equivalent length. So if K is the midpoint of AB and L is the midpoint of CD, it implies that they divide these two so that each of these little portions, AK, KB, DL, and LC, are all equal to each other. All right, and I just want to prove that to you a little bit further. Let's look at it in terms of numbers to understand what we're saying here. So say, for example, AB was the length 10 units. All right? Now, if K is the midpoint of AB, that means the distance from A to K, because K is the midpoint, would be 5, so it's exactly halfway. And then KB is also going to be 5. All right? Now remember, because it's a palm, if AB is 10, then DC would automatically be 10 as well. And since L is the midpoint of DC, the point L divides the line DC so that you've got, again, two equal portions. So if the whole length is 10, then LD will be 5, and LC will also be 5. So therefore it implies these midpoints are exactly going to divide the lines equally so that each of those little portions are equal to each other. All right, so that's just a little side explanation to help you guys understand why we can make the statement that I'm about to make now. All right. So we're going to say, since AB is equal to DC, we've already said that, AK is equal to KB and DL is equal to LC, this implies all the little portions are equal to each other. Okay, because we're dealing with the same lengths. So AK is equal to KB is equal to DL is equal to LC. And the one I'm really interested in is KB, this one, and DL, because those are the opposite sides of my potential parallelogram KBLD. So I know if all the little portions are equal to each other, this implies from here KB must be equal to DL. Alright, so KB is equal to DL, and we also know, so still working in KBLD, we know that AB is parallel to CD. Again, opposite arms of your palm, ABCD. All right, opposite sides are parallel. So AB is parallel to CD. If you look at KB and DL, KB and DL are just continuations of that line, AK and LC. So they fall on the same straight line as AB and DC. Therefore, if AB is parallel to DC, it implies that KB, which is a part of that line, would be parallel to LD as well. Okay, so therefore, KB is also parallel to DL. Okay, so now we've got what we need. We've got KB parallel to DL, and we've also shown that KB is equal to DL, so we can say, therefore, KB DL is a parallelogram. Obviously, remember, whenever you make a statement, you need to give a reason for that statement. And the reason that KBLD is a parallelogram is one pair of opposite sides is parallel and equal to each other. Okay, obviously the sides we're talking about there, KB and DL. All right. Okay, so just to recap, all we did with this, guys, question 1, is we looked at the quadrilateral KBLD. We then attempted to show that that quadrilateral had one pair of opposite sides, both parallel and equal, and therefore by showing that there's one pair of opposite sides parallel and equal, we could conclude that that quadrilateral was in fact a parallelogram. As you can see, it's very important to understand your theory and your properties of quadrilaterals if you hope to get your application of that correct. All right, I think with that, it's probably time for us to take a quick break.
Thank you so much, Natasha. Well, during this break, Mindsetters, you have the challenge question. And I must also remind you that we still have more maths, our mathematics application, where you can challenge yourself and challenge other Mindsetters with what we're doing today. So get on moremaths.org and then register there. After registering, take those questions, test yourself as well, and we'll see you after this break. Welcome back, grade 10s. I hope you're still enjoying the show, and thanks to those Mindsetters that are chatting with us on Facebook and also sending us their answer to the challenge question. Guys, it is a nice challenge question. Trust me. Try it and see if you could get the right answer. On the mobile maths that I spoke about earlier on, you register on moremaths.org, and your code is 2FB5. 2FB5, and that's all you need to know. Otherwise, more information on facebook.com/learnextra. And I do challenge you guys, as Natasha said, that we need to get your questions, guys. If you're struggling anyway, any question that you have on Euclidean geometry, which is what we're doing now, send them through, guys, and we'll help you after the challenge question. Thank you, Natasha.
Great. Yes, AB, I have to second that. If you guys are struggling with anything in geometry, let us know. Let's sort those problems out. Okay, but let's get straight into question 2. you're told that ABCD is a parallelogram where DE is parallel to BF. All right. And then they ask you to prove that two of the triangles are congruent. Firstly, because they've told you ABCD is a parallelogram, there's things that you can mark down on your diagram. We know that the opposite sides are going to be parallel and equal to each other. So AD will be parallel to BC, and AB will be parallel to CD. They gave you the middle blue ones, that ED is parallel to BF, and that's probably what you're going to use in your proof. All right. The other thing we know from the POM ABCD is that AD will be equal to BC, and AB will be equal to CD. We also know, obviously, our other things, diagonals bisect each other, and your opposite angles are equal. All right. They ask you to prove that triangle ABF and CDE are congruent. Okay, so these are the ones we're talking about here. ABF, there you go, and CDE. So let's prove that those triangles are congruent or identical, right? All right. Now remember, guys, when you're dealing with your congruency, you've got a couple of reasons that you can fall back to prove that triangles are congruent. Okay, one of those reasons for congruency is angle side. So you prove that two angles are equal and one side is equal. The other one you can use is side angle side. Just remember, when you're using side angle side, your angle needs to be included between the two sides. So we've got angle side, side angle side. You've also got side side, so showing that all three lengths of the three sides are exactly the same. And then you've got right angle hypotenuse side. Alright, so the right angles, obviously your 90-degree will be the same. Your hypotenuses, or your hypotenuse, how do you say that, AB? Let's throw an English question out there. What's the plural form of a hypotenuse?
Okay.
What is it? A hypotenuse?
Let me ask the mic.
All right. So your hypotenuse and your sides are the same. All right. So those are the four different things you can choose from when you need to prove congruency. All right. And we're going to look in our true triangles and see which one best suits these triangles. All right. Let's mark down what's already we can see straight away. We know for a fact AB is equal to CD. So we've got a side. Now let's have a look at the angles. What angles can we use? All right. Now guys, this one it needs a little bit more thinking. We've just got to look at it a little bit harder. Remember, AB is parallel to CD. Therefore, you get all your special angles. Something like alternate angles. All right. That's your Z shape there. We know that alternate angles are equal, and since AB is parallel to CD, we can say angle A is equal to angle C in that triangle because of alternate angles. Okay, so we need just one more thing. We don't have any more sides, and that's where the bit of information that they gave you, that ED is parallel to BF, comes into play, because you know that if those two lines are parallel, it means that E1 will be equal to F1 because alternate angles. All right, so you've got that Z going like that. There we go. Okay, so you've got alternate angles here with F1 and E1. So what do we have? We have angle, we've got angle, and we've got side. So our reasoning we're going to use here is number one, angle, angle, side. The set out is very important. So we start with in triangle ABF and triangle. So we went ABF. So then we've got to go CDE. All right, the order is important. So in triangle ABF and CDE, let's list what's happening there. We know that angle A is equal to angle C. In fact, we're going to be a little bit more accurate there. That's because of alternate angles, and we know AB is parallel to CD. All right, when we're looking at angle A and C, angle A is obviously the whole big angle, so it's going to be angle BAF if we're strictly speaking. So it's angle BAF is equal to angle DCE. All right. Number 2, we know that AB is equal to CD, and that's because we know that ABCD is a palm, so opposite sides are equal. So we'll say opposite sides of palm ABCD. Right, and then lastly, from the given parallel lines, we know that E1 is equal to F1, so angle E1 is equal to angle F1, and that's because the lines that they told you, DE is parallel to BF. Okay, so they gave you that bit of information. Okay, so we've got angle, angle, side, so therefore I can say, therefore, triangle ABF is congruent to triangle CDE, and your reason there is angle, angle, side. All right. Now the last bit here, it says, prove that D1 is equal to B1. So D1, this guy there, prove that that's equal to that. Now guys, remember, whenever you prove that triangles are congruent, it means that they are exact copies of each other. So you can take this triangle and lay it flat on that triangle. They will match up perfectly. One of your deductions from congruency in these two triangles is going to be that D1 and B1 are going to sit on top of each other. So therefore, B1, so this is part 2, angle B1 is equal to angle D1, and your reasoning there is just because the triangles are congruent, or you can say deduction from the congruency. Okay, so you just deduce that from the congruency. All right. Okay, so hopefully you all got this, and you're all with us so far, and you also have your own questions for us, and we'll get to those a little bit later on. But AB, is everyone still following me?
They're still following us. They gave us answers for the question that you...
Hypotenuse or hypotenui?
There are so many different views, Natasha.
Yeah.
Maybe you want to hear these.
Yeah.
Okay, let me get to them. Give me a sec.
Okay, so the big question here, guys, is how do we pluralize, if that's a word, hypotenuse? I think you can say hypotenuses, but it sounds very odd.
Okay, some do say hypotenuses. Some says it does not have a plural. Ask Google. Some say hypotenia.
Hypotenia.
Yeah.
Wow.
And others say hypotenu. Some just say adjacent, some hippo. That's it.
All right. Okay, well, I think let's stick with hypotenuses, because, yeah, even though it doesn't sound right, you know, sometimes you just hear those words that don't sound right. Doesn't sound right, but I'm sure it's correct.
Yeah,
Hypotenuses.
I'm sure it's correct.
That's the one we're going to
Yeah.
go for. All right, great. So now that that riddle is sorted, let's go on to question 3.
All right, here's a question, a quick question from on the previous question.
Okay, let's go back there.
Based on your answer, Tato asked, will I be wrong if I don't write reasons?
Oh, for which part?
Well,
For the whole question?
for the whole question.
No, it's very important, guys, that in geometry, remember, you get 2 marks here. You get a mark for a statement and a mark for a reason. So, Tata, you have to put down your reason, because if you just make a statement, how do we know that you deduced that correctly? So you have to actually make a statement, give a reason every time you make a statement. So if you're going to say, for example, angle A there is equal to angle C, you need to tell us that the reason behind that is that it's alternate angles. All right, so it's very important. In geometry, you get marked for your statement and your reason. If one of those is missed, well, obviously if you don't have a statement, you're not going to get any mark. But if you put your statement down and no reason, you're only going to get half the amount of marks. Okay, so be careful. You need to put everything down. All right, is that it, Abby?
That's it.
Great, thank you. Okay, so going back to question 3, we've got KLMN is a parallelogram where KX is perpendicular to LN, that's noted on your diagram. MY is perpendicular to LN, and then they ask you again another congruency and then to prove that something is a parallelogram. Alright, so let's have a look first. We're looking at triangle KLX and triangle MNY. So that's going to be this one, KLX and MNY. So I've already shown you what the 4 possible reasoning for congruency could be. I'm not going to re-show you that. We're just going to see what is applicable to these triangles. Alright, so if we look within KLX and MNY, firstly we can see the thing that stands out immediately, and because you guys are so good now with your properties of palms, the thing that you can get immediately is that KL is equal to NM. Okay, and that's because of opposite sides of palm, KNML. Alright, so that's immediate. You can put that down without even really thinking too hard about that one. Okay? It's actually a very similar proof to the one we've just done now, because we can also say that L2 is equal to N2, and the reason for that is alternate angle. So if we follow that Z shape there from KL all the way to N, okay, you guys can see that Z. You've got L2 is equal to N2 because KL is parallel to MN. So all we need now is one more point, or one more reasoning, or one more reason in order to say that these two are congruent. We see that this angle X here, KXL, is 90 degrees. All we need is for this angle here, NYM, to be 90 degrees. And you can see that because we know that MY is perpendicular to NL, which they gave you, angles on a straight line would make that angle there 90 degrees. All right, so we're just going to make a quick statement here. Well, actually, let's write down the whole proof and we'll go into our statements and reasons as we do it. So we're going to say in triangle KLX and triangle, so we went K, we went L, we went X. So here we've got to go MNY. Okay, so in those two triangles, let's list our reasoning. We know firstly the most obvious thing, KL is equal to MN, and the reason for that is opposite sides of palm, KL, MN. Alright, so those are equal to each other. The next thing we know is that angle L2 is equal to angle N2, and the reason for that was alternate angles. KL is parallel to MN. KL parallel to MN. And then the last one is the 90 degree that we saw there. We know that the lines were perpendicular to each other, so we're going to say angle KXL is equal to angle NYM because they're both equal to 90 degrees. Okay, and we can add a reason onto why NYM is equal to 90. We can say angle NYM is equal to 180 minus 90 degrees because of angles on a straight line. Okay, so that's how we got to that reasoning. that NYM is in fact 90 degrees. So what do we have? We've got angle, and we've got side. So therefore, once again, the reasoning, as I said, very similar to the previous one we did. We'll say, therefore, triangle KLX is congruent to MNY. And your reason here was angle, side. Alright, so that's the first part done. The next thing they ask you to do is to show that KXMY is a parallelogram. Alright, so let's just highlight that. Remember, we're now assuming, because we've proved that those two triangles are congruent, we're going to assume all the results from that congruency. Alright, and we're looking at KXMY. So I'm going to join those two together so you get an idea of the quadrilateral we're dealing with. Alright, and we need to prove that this is a palm. So what do we have? Remember, from your congruency, we're going to use the deductions. Obviously, I'm going to write it all out. But from your congruency, we know that YM is equal to KX. That's a deduction straight from your previous question from your congruency. So KX is equal to YM, deduction from congruency. All right? All you need is for KX to be parallel to YM, and if it is, then you've got your reasonings here for this to be a palm. All right? And it is actually parallel because, remember, using angles on a straight line, this one here, KXY, is also going to be 90 degrees, and we were given that this one, XYM, is 90 degrees, but those angles are alternate. And if they are alternate, then we know that KX must be parallel to YM. All right, so let's state our proof there. Okay, we're going to start with the parallel lines firstly. So this is now number 2. We know that KXY, angle KXY, is equal to 90 degrees, and the reason for that is angles on a straight line. Alright, and that's also equal to angle XYM. Alright, and this is equal to angle XYM because that's also 90 degrees. But these are alternate angles. Therefore, we can say, if those are alternate angles, that means that KX must be parallel to YM. So KX is parallel to YM. Alright, so KX is parallel to YM, and we also know KX is equal to YM, and that was because triangles KLX and MNY were congruent. Okay, so that was your deduction from that congruency. Therefore, what do you have? One pair of opposite sides parallel and equal. So therefore, what's the name of the palm? KXMY is a parallelogram and the reason for that is one pair of opposite sides parallel and equal. Alright, great. So guys, you can see that this kind of question is quite common. It's important that you understand all of the stuff you learned from previous grades. I said this before when we first started looking at geometry. You need to remember all the stuff you did in grade 9 and all the stuff you did in grade 10. Angles on a straight line, your co-interior alternate corresponding angles, and obviously your similar triangles and congruency that can and will be tested again in grade 10. All right, AB, if we don't have any questions, we can go straight to a break.
Yes, I think we should. And during this break, the challenge question is still waiting for you guys. And let us know how you guys are doing. Are you coping with geometry? Do you have some questions? Feel free to throw them at us on facebook.com/learnextra. We'll see you after the break. Welcome back, awesome mindsetters. Now, I need to announce to you our winner for the Casio calculator from our last week's show. Natasha was going to say, help me with the drum roll. Drum roll, please. We need a real drum, hey?
Yes, we do.
Okay.
We do. I'll bring my bongo drums the next time.
All right, cool. Well, our winner from last week is Kainon Sibuyane. Congratulations to you, Kainon Sibuyane. This awesome Casio calculator is coming your way. And if you'd like to win and you've been entering our Vodacom Get Connected competition, today, we're doing a draw at 6 o'clock, whereby we'll be announcing a winner of the Sony Xperia L cell phone. So we've got all the names. So hopefully at 6 o'clock, it might be your name. So if you haven't entered, tomorrow there's going to be a new list of the new teachers that you need to vote for, and you need to share that copy with your friends and your classmates and vote for your favorite teacher. And also, lastly, we'll be announcing the Vodacom airtime winner tomorrow. Winners, actually. We've got 10 of them. So tomorrow, we'll be announcing them. Natasha?
All right, Abby, that box looks quite heavy, so hopefully there's quite a few mindsetters' names in there. All right, guys, so hopefully you all have had a chance to do the challenge question by this stage in the show, and you got to this proof, or you got to state it correctly. All right, you're told that ABCD is a parallelogram. And again, just to remind you, as we've been doing throughout the lesson, when you see a statement like ABCD is a parallelogram, things like opposite sides are parallel need to come to mind. So AB is parallel to CD. Also, AB is equal to CD. We also have AD being parallel to BC, right? And AD being equal to BC. All right, so you need to know what all your properties are for the given diagram. We also know that the opposite angles of a palm are equal, so A would be equal to C and D will be equal to B. In this diagram, we don't have any diagonals, so we're not going to really be interested in the diagonals bisecting each other. All right, so all of that information needs to come to mind when you look at the given information and you look at what they're saying to you. And I always like to just mark everything down on the diagram before we actually attempt the question. All right, so the one thing that we do know that I'm going to put in is angle A is equal to angle C. Okay, they tell you that C1 is equal to C2, so angle C1 is equal to C2, so these two are the same. And then they also tell you that D1 is equal to D2. So those two are the same. All right, so RD is the bisector of angle D, and RC is the bisector of angle C. They say angle A is equal to 2x, so this one here is 2x. And they want you to show that angle R1, this guy, show that that is 90 degrees. Okay, so from the information that they've given us, let's write down what we know. Okay, we know that opposite angles of a palm are equal, and what I'm going to do here, because I see I've used the symbol X to indicate that those two are equal, but it could be confusing because we're already dealing with X's here, so let's just use little blue lines. Okay, so those two are the same. Alright, so as I was saying, we know that angle A is equal to C1 and 2 because opposite angles of a palm are equal. So that means angle C must be 2x. Alright, but remember, RC is the bisector of angle C. So C1 and C2 are going to be exactly the same. The whole thing is 2x. If I divide by 2, I'm going to get x and x. So therefore, C1 is x and C2 is x. Alright. We also know that AD is parallel to BC, so that implies that angle D, the whole of angle D is going to be 180 degrees minus angle C. And the reason for that, guys, if you look at your drawing, you know you're dealing with parallel lines, and we're dealing with, in this case, co-interior angles. So angle D plus angle C is 180 because they're co-interior angles. So therefore, the whole of angle D is going to be 180 minus 2x, right? And therefore, each of these, because D1, remember, that one was equal to D2, okay, we can take 180 minus 2x, divide by 2, and that will give us the value for D1 and D2. So that will give us 90 minus x. So each of these are 90 minus x. And then, because remember, ultimately we want to get to R1. So why did I have to go through all this work? Well, I used the given information. So I used the fact that they gave us the two angles were bisected. I needed to use that information to get into that triangle RDC. In that way, I would be able to work out angle R1. So I needed to get into that triangle with as much information as possible and then work out angle R1. All right, so we know that D2 is 90 minus x. We know that C2 is x, and we will therefore be able to show, using angles of a triangle, that R is in fact, R1 is in fact 90. Okay, but remember, what you do in the diagram is not the main thing. What you actually write down is important. Okay, so here's our proof. So we were given that angle A is equal to 2x. So we know that angle A is equal to C1 plus C2 is equal to 2x. And remember, if you make a statement, you need to give a reason. The reason there is opposite angles of a palm. Alright, so A is equal to C1 plus C2, which is equal to 2x. But we know that C1 is equal to C2. And if we take 2x and divide it by 2, we'll get that they are each equal to x. Alright. Then we can say angle D1 plus D2, so basically the whole of angle D, is equal to 180 minus angle C, and the reason for that is co-interior angles. And you can state your parallel lines there are AD and BC. Okay, so angle D is 180 minus C. So therefore it implies that D1 plus D2 is 180 minus 2x. Alright? But we know that D1 and D2 are equal to each other. So D1, angle D1 is going to be equal to angle D2 is going to be equal to 180 minus 2x divided by 2. And that's going to give me 90 minus x. So each of those angles is equal to 90 minus x. All right. In triangle RDC, we now need to work out angle R1. So we can say, well, angle R1 plus angle D2 plus angle C2 is equal to 180 degrees, and the reason for that is sum of angles of triangle. Alright, so we've got that R1 plus D2 plus C2 is equal to 180 degrees, but remember, we know what each of these are, so we can put them in. D2, 90 minus x, so we put that in. Plus C2, we've already shown that that's going to be just x, alright, so that's going to be plus x, and that's all equal to 180 degrees. And we're just looking for R1, so we take everything over to the right hand side. You can obviously see already if you start adding here minus x plus x, those are just going to cancel. So we're going to get R1, angle R1 is 180 minus, if I take that over, minus 90, and therefore angle R1 is 90 degrees. Okay, so we've got a right angle triangle, and angle R1 here is in fact 90 degrees. Okay, I'm hoping that a lot of you got that answer. I know with geometry, it's quite difficult to post your answer because it's a whole long reasoning, but I'm hoping that most of you guys were able to reason this out. And as I said to you, all you do is you use the given information, you use the properties that you know are inherent in a palm, okay? You know what makes a palm a palm. You've got to use those properties in order to assist you to answer this question and any question in geometry, really. I'm going to quickly check with AB to see if we've got any questions from you guys at home.
Yeah, actually there are so many questions.
Okay,
So
great.
thanks to the masters. First one is from Isohono Masiza. How do I prove that a triangle is RHS?
All right, so I think what he's asking here is prove that a triangle is RHS. I think he's asking how do you use the reasoning from congruency, right angle, hypotenuse, side. So I'm going to just use this page here. And let's see if we can quickly draw one for you before we run out of time or anything like that. So when you're dealing with right angle, hypotenuse, side as a reason for congruency, you need to be given your right angle triangle. You'll already be told that those two angles, so if we call this ABC and DEF, okay, you'll need to be given your 90 degree. You'll also, because remember the reason is right angle, we've got that, check. Okay, hypotenuse. So you also need to either be given or you need to be able to show that your hypotenuses, as we decided on that name, are equal. So we need to prove that AC is equal to DF. If we don't prove that, maybe it will be given to you. And then your last thing would be the side. So there needs to be some other side in this triangle that's equal to each other. So for example, BC could be given as equal to EF, or you could have DE equal to AB. There's no restriction on which side. All right, so for your right angle hypotenuse side reason, you need to have your hypotenuses equal, you need to have your 90 degrees, and then one of the other sides equal to each other so that you can use that reasoning for congruency. All right, Abby?
Okay, I hope you answered on that one. Here's another one from Tato. Tato says, how to find out an area of the right-angled isosceles triangle?
All right, okay, that's not quite in keeping with what we're doing, but if you're talking about areas of triangles, remember guys, in geometry you need to learn all of your properties and you also need to know all of your formulae, volume, area, the rest of it. We are going to go into later on lessons where we look at what we call mensuration, which is volume, total surface area kind of thing. But if we're looking at a normal flat triangle, the area of a triangle is half base times height. Okay, so that's the formula. It's just half your base times your height. What I do want to mention, you guys, is we haven't done any questions on midpoint theorem today. That doesn't mean it's not important. It is very important. I just remember that a while back we spent quite a lot of time just looking at midpoint theorem. You guys, please, I can't stress enough that midpoint theorem can be incorporated into questions on parallelograms as well. So make sure you understand what the midpoint theorem says and how to apply that theorem. All right, AB, anything else?
Lastly, is it not wrong to write a shortcut like you wrote D equal to 180 minus C?
Is it not wrong?
Yes.
Is it not? So there's two negatives in that question. Is it not wrong to write angle D is equal to 180 minus angle C? No, there's nothing wrong with that. I said angle D is not a shortcut. Angle D, we've got our little copy there, is equal to 180 minus angle C, and the reason for that was co-interior angles. There's nothing wrong with that statement because, well, it's true. So there's nothing wrong with that statement. It's not really a shortcut at all because we mentioned the angles.
Awesome.
All right, is that it?
That's it, Natasha.
Great.
Thank you so much.
Thank you guys for joining us.
And thank you, Natasha, as well. Thank you, guys. Really appreciate it. Up until next time, we as the Mindset team, we just want to leave you in peace.